All right. Hello, everybody, and welcome to the September 3rd, 2025 iteration of the Hyperlight biweekly community meet or fortnightly community meeting. These meetings are recorded and uploaded to YouTube and are under the CNCF Code of Conduct. There's a link to the CNCF Code of Conduct at the top of the agenda. If anybody's interested in reading that, but it pretty much just boils down to be nice to everybody. All right, let's get started. I think we've got some announcements. Does anybody want to cover some of the highlights of the releases in the announcements?
I think we can mention it's a rather smaller release compared to 0.8. There are some bug fixes, especially some around the widget generation. I don't know if there's much more.
Looks like
A couple things around
a removal that might be
serialization.
worth
Yeah.
mentioning.
Yep, there's a couple other bugs, and then there was a serialization improvement on the host side. So we're seeing some
Is that this one?
increased performance on the host calls.
All right. I think that's good for that. Probably start jumping to the discussion items. I see the muzzle builds PR. Is this you, James, working on
Yeah,
this?
I just threw that on there. So I got this going. There's a couple like little things that I just disabled to get it moving. But one thing, we need some changes on the VMs that we use for the build VMs. I went to go add the libraries to build muscle on Azure Linux, but they don't have those packages. And I kind of feel like we're probably okay skipping that for now, but I just wanted to know if folks thought what they thought about that. And then I guess we could potentially I think what's more important is that we are able to build it on Ubuntu and then be able to run and test it on Azure Linux. But I wasn't sure the effort to like get a package running in Azure Linux and everything and hosting it and building it and stuff. I felt like it was a
Can you
lot.
run Docker?
Yeah. So I did actually take a look at trying to add cross, and then cross required quite a bit of extra work, and I was trying to get this forward so that we had some validation. And so yeah, I think we potentially could, but we'd have to integrate cross.
Okay.
A bunch of extra work on top of that. So
Yeah, did we check with anybody on who owns the packages at Microsoft.com to see if they might be there? Sometimes they're renamed or under a slightly different, like,
I went to the Azure Linux like package repository and searched around. I didn't find anything, but I might have missed it. So if you have a contact, you can send me.
yeah, I can maybe take a look after this.
Yeah.
I
So
think it's probably fine for now to show that this is working on Ubuntu. Go ahead, Jorge.
I'm curious to what kind of extra changes you needed for cross support. It should be kind of like just replace cargo with cross, and it should work out of the box.
yeah, I think you need to map like the devices in and a couple other things. And so wiring that through all of the
that's for running
tooling.
the tests.
What's that?
That's for running the tests, not
Yeah,
for building.
Oh yeah,
Okay,
yeah. So I also this enabled running all the tests and things as well.
Okay, because I think an approach would be building with cross and then just running locally in the host.
Yep. I think I can look at it again, but I think it would require some changes to like the whole just file pretty extensively. So All right, cool. I'll take a look again. Just gotta bring it up here. If somebody wants to take a quick look at it and give some feedback, that'd be useful as well.
Yeah, I'll try and take a look and also look to see if there are some packages, maybe preview packages too. Yeah, I think that's the end of what was on the current agenda. Does anybody have anything else they want to add to the agenda? Not.
Yeah, a bit ad hoc. I've been working like there's a pain point, which is when we try to build guests for Hyperlight, especially like guests that depend on C dependencies, like using CC or bindgen. It's a bit tricky to get it right. And also there's some issues that we're currently having around like the API that we expose. So I've been working on something trying to fix it called Cargo Hyperlight, which is like if you install it, it adds a subcommand to Cargo. So you can do Cargo space Hyperlight, and then you can do build. And it's intended to build guests for Hyperlight, and it basically follows like what the experience tells me are the best practices for those kind of situations. And also it introduces a custom target where we can configure things like what API we want to use and things like that. That should, like currently we're using x86, 64, and no none, and that's kind of like a happy coincidence that works for us. But we could define our own target with our own custom API that we choose without having to upstream that to Rust C, and we can experiment a bit on what we want to, and then when we are set with that, we can upstream things. So yeah, yeah, it's called Cargo Hyperlight. It's on my GitHub. So I would appreciate if people want to try it and like see if it works for them and if it makes things easier.
Would you want to do a quick demo of that? I know it's maybe putting on the spot, but that might be interesting to see in action as well.
Sure. Let me see. Let me grab Hyperlight repo.
I think, yeah, solving the issue with the targets without needing to upstream them right away, I think would be super valuable.
Let me see how to share my screen here. Share.
Let me see.
I cannot share.
Can you share now?
Yes.
Okay, I think it's set for only one person at a time.
Can you see my screen? No. Yes. No.
Yep.
Okay. So this is a Hyperlight folder. So here we have the different tests that we have. So Rust guest, this is simple guest. So if you see, this is the source, test, Rust guest. Okay. So to get this working, usually like you have to define things in config.toml, like the target you want to build, and also some Rust flags that you need for the linker and extra configuration that's not there. Like code model small is because that's not the default for x86 for unknown none. Also, if we were using something like C dependencies, we would need to define even more things, like where to find CC, where to find Clang, and we would need to follow some special steps to build Clang. So instead of that, like here, if I do cargo build, it follows these instructions, and I think that just works. However, we can do cargo Hyperlight build. And what it does, it gets the sysroot. It builds a sysroot for a custom target, which is called, as you can see here, x86-64 Hyperlight none. Although that's we've been discussing that probably that's not the best name for the triple. And yeah, it defines like the environment variables. You don't need any of this, so we can do. We can just get rid of that file. And we can do. So we're back in the simple cast, and we can do cargo clean, and then we can do Hyperlight build, and it should work. And you don't need any special configuration for that to work. You don't need to specify the entry point or any of that.
Yeah, I mean, I
And the
think
target
this
is
pretty cool. I did try it out yesterday, and with your help, was able to get the Hyperlight WASM guest to build. Today I was gonna see if I can try adding the ABI float just to see how if we're able to solve it through that process, which I think we would be able to.
yeah, that would be great if we can solve that issue using a custom target. Yeah, I wanted to see, like, say, without that cargo.config here, if we do cargo build, of course, it's not going to work because it doesn't have the right target or anything. So yeah, one of the things, like, for instance, if you're building something that has a C dependency, first you need to get the clan wrapper. And to do that, first you have to build the Hyperlight guest bin package that installs the wrappers depending on an environment variable that you set. So that's not very like obvious to do. So it does that for you, and then it sets environment variables that CC would expect, so that it knows where to find clang, and also for bindgen, so that it knows where to find clang. I didn't do anything for CMake, for instance, so probably CMake wouldn't work. But if you have a C dependency using CC or bindgen, that should work. Yeah, that's it. It's very basic. It's just a cargo wrapper for building.
So yeah, I think it'd be very handy.
Be interested in hearing what other folks think.
Is this something you think we'd want to integrate into our CI as well?
I think it would be good, especially, I don't know if in Hyperlight CI we need it so much, but in Hyperlight WASM CI, for instance, it would be nice. Also, like, Hyperlight WASM has a build script that's a bit complicated because it has to build Hyperlight, the WASM runtime. And for that, it has to call cargo, and it has to follow all these best practices because it has some C dependencies. So in that case, I think it would be easier in CI just install this subcommand and use that instead. Alternatively, I think another option would be making this subcommand a library so that you can add it as a dependency in your build script and use that programmatically instead of having to invoke the cargo Hyperlight build process.
Yeah, very cool.
Cool. I'll be trying it on the ABI today and let you know how it goes.
Does anybody have anything else they'd like to discuss today?
Yeah, I do have one question. So I'll share something and then ask something maybe someone can help me with. Let me know when you can see my screen.
All right, I think we can see it now.
Uh, okay, so this question is related to tracing. So I'm working on improving the tracing experience we have on the Hyperlight guests. So I'm trying to merge the traces we've got from the guests with the ones from the host. And I'm doing that through using open telemetry on the host. And the current state is the following. So I've got here an example run that what it does is it calls initialize and then calls two functions in the on the guest. One is echo and the other is printf. So on the initialize, we can see that it has some things on the host here, and after the run call is made, these two spans happened in the guest, calling Hyperlight main, and then halt. This is nice. The same happens for the when calling echo. We can see here we've got we first enter the dispatch function, the internal dispatch function, and so on, and finally we call echo that was defined on the simple guest sample we have in Hyperlight. This all goes well. However, the tricky thing is when we have a call from the guest to the host back. So we have dispatch function, we call guest function, and at some point we want to call back into the host. And what it does is it calls it executes the out instruction. And when this happens, it yields back control to the host. And at that point, we would expect that the traces that are the spans that are captured on the host to be visualized as children of the out32 span, right? Because out32 hasn't finished yet, hasn't exited. But that doesn't happen at this point because I do not have a way to propagate that context of open telemetry. And my question is, so I need a way to exchange data between host and guests right before and after calling the out instruction. And I cannot do that through the input-output buffer we have now because where the out implementation is done is in the Hyperlight guest crate that doesn't have access to the guest handle that handles the actual call to the host. So I'm not sure how to handle this data exchange of context so that I could correctly map these spans to their parent. Do you? I'm not sure I'm explaining it well. This is the best I think I can explain it at this point. But this is the current state. Do you have any questions, thoughts, maybe things that I could do better? Don't mind the numbers on the right-hand side because there's a bug with the spans that go back to the host at this point. So the numbers aren't accurate at this point.
So does this boil down that you just need a way of sending extra data whenever there's a function, a host call?
Mm-hmm.
It-
Yes.
would that solve
Go on.
the whole issue?
Yes, but the thing is that I cannot. So when you call, when you want to call a host function, you have another tree of calls that are being made. So I cannot freeze the state right before calling the function because after calling the call host function, for example, it has a lot of other spans that are created, and I would like those spans to be included in that context. So I need that context to be sent to the host right before the out instruction is issued.
So we talked briefly about this, but we currently, before doing the out instruction, we fill out the buffer, the I/O buffer, with things like the function call.
Yeah.
Let's say the function call had an extra field for metadata. Could you use that metadata field to add the tracing context information?
Yes, but what I was saying was, if you see this call tree here, so you call host function, you call another call host function without returning result, and this, at this point, push shared output data is where you push the function call structure we have, right? But in between the push shared output data and the actual out instruction, there might be other spans that are created. And you would want those spans also to be in that context, right? Because they would be
okay,
children.
I see. But we're fully in control of that. There's never going, like, if there's another span, it's because we put it there.
Yeah. So that would mean we don't want to instrument other functions inside this call host function without returning results, right? Right. So would we be okay with that? Saying that, well, we don't want to instrument, for example, this out32 function here. This would, if I commit to what you proposed, was that this span right here, we won't see it, right?
Yeah, I think I personally find that that's fine. And especially, like, we could have a test to check that there's nothing in between, or like, so if we break it, we can go and fix it. I think it's fine because we don't expect consumers to be able to break that. As long as we don't break it, consumers are not going to break it.
Okay. Okay. So then I'll try and add a metadata field or something like that to the function call that would only be enabled when tracing is enabled.
Yeah,
Okay.
I don't know if like a metadata field is the right approach. I'm just like trying to understand the problem.
Or another push to shared output data also would be reasonable.
Yeah.
Okay. And I wanted to show something else. So I think James.
David wanted to say something.
Oh yeah, David.
Thank you. Thank you all. Not to be really pedantic, but the titles for the spans, do you intend on changing that? So the actual, like, the dark black, the bolded
here
part of well, so that does stutter. So you see Hyperlight Hotel example, that's the name of the example, Hyperlight trace example thread. Each one of your spans has Hyperlight underscore hotel underscore example. So that's the name of the application. That should definitely not be the title of the span. So you may want to consider what attributes and how you're using the titles and metadata so they show up appropriately in tooling like you're showing in Jaeger.
yeah. Sorry for interrupting you, James. This is configurable from the application side, from the host application side. So it doesn't have to do with the guest traces coming back. So this is the way we had it configured in the example. If I configured it in another way, we won't have these names here.
What metadata field is that using?
Let me show you. So
it shouldn't be service name.
Service name, here it is with service name. Source builder. Yeah, okay, I understand what you're saying. Okay.
Yeah, I'm not sure what attribute I think it should be a different attribute. Whatever is being shown in the title there, that title attribute doesn't seem like it's filled in correctly. Usually you'd see like the function name.
Okay.
Because imagine as you're going through this and you're trying to diagnose what's going on.
Yeah, I understand. Okay, one more thing I wanted to show was I got a question from James. How do you differentiate the traces coming from the guest from the ones from the host? So I think we can do something like this. Guest trace, I think, is the other way around. And this is configurable by, and you could have them filtered by this tracer name. For now, I just called it guest tracer, but we can call it something more appropriate, let's say. Yeah, this is all I wanted to share with you. Thanks for the feedback. I'll try and do what we talked about overhead and come back with the results. Thanks.
Thank you, Daryl. This is looking really good. Helps a lot with understanding what's going on.
Yeah, great work, Tor. This is really cool.
Thanks.
Cool. Looks like Mark had to go to another meeting. Jorge, you had added another item here.
Yeah. So another thing I've been, I have currently a PR app for, but is, so I've been writing guests lately, and I find it a bit verbose the way we register host functions, or the way we call host functions, and the way we register guest functions in the guest. So I went and dig something that I had been working on a few months ago, writing some macros for the guest to simplify that process, and I put up a PR for that. So I wanted to show you how it looks, and I wanted to tell you about some of the downsides of that. Okay. So I took the simple guest and used the macro for that. So you can see the differences in the changes. So before, if you wanted to call host print, for instance, you would have to do something like this. You get the response from the function call host function, and then you have to specify the name, and then you have to create a vector from the, like, specifying the type of the parameter value based on, so you have to specify the return type here. It's a bit like verbose just to say print a message. So print this thing that you had here. So I created a macro that basically it takes a function declaration, and it takes a signature, and you can optionally specify the name that you want to use for that, and it just does that for you. So it uses traits to identify, like, this is a string, so it knows how to build the vector from that thing. So if you had more than one input, like here you have two, it knows how to build the parameter value based on that type, and then how to create the vector, and then it uses the return type just to like, it has all the information you needed to build that call. Also here you can specify result instead. You can specify I32 instead of a result. In that case, if it was an error, it's going to panic. But you can also specify result, and understands that. So that's like calling host functions. So the idea is that you don't have to do all that verbose stuff just to call a function in the host. The other thing is registering a guest function. So before, like, when you create a guest function, you have to create a function with a signature that takes a function call and always returns a vector of bytes. And then you have to take those parameters out of your of a vector of parameters and then cast them and then handle the error case. And then do whatever you wanted to do inside of that. So in this case, it's just returning the same value. Let's see something a bit more interesting. So here, print two args. This basically wanted to print an output, which is a formatted message. So the interesting thing is this, but you have to have all of this around. So basically, it's a macro, again, that takes the name that you want to register this function with. It's optional. If you don't specify it, it uses this. Also, you specify the arguments, and it does all the parsing for you. And you specify the return type, and also it does the conversion into this vec U8. And the function that you wanted to write, it suddenly is much easier. And also, you can combine that with the host print that we defined with the other macro before. And yeah, it makes your life easier. And that's basically the two macros. It's all it does. There's a little bit of magic, and is that by calling this macro, somehow it's creating a static that then is going to be picked up. Oh, sorry, and something else I didn't mention is that now none of this has to go into your Hyperlight main. This Hyperlight main is basically an empty function, and it handles all the registration for you. And that's where the bit of magic happens. It's using a crate called linkme that lets you create distributed arrays. So every time you call this macro, it adds a member to that distributed array, and it uses some linker magic. But there are some issues in LLD. Some issues in Rust-C where there's an attribute that's being passed with the wrong value to the linker, and that's fixed in 1.89. But for lower versions, you have to specify the set no start stop GC linker parameter for that to work. Otherwise, you get a linking error. So there's a little bit of magic of the auto registration, but it has this cost. And if you're using the cargo Hyperlight wrapper, it adds already that flag automatically. Also, one of the prices you pay for doing this is that you don't get all the dynamism that you had before from that was possible before. Like before, you could write a function that takes a variable number of arguments, and that worked. A function that takes different type of arguments, and then you could do runtime processing of that. Since this is all handled from the type system, it's all at compile time. You have to know all your types, and you cannot do dynamic things. So things like what we were doing in the dynamic dispatch here, where we basically take at runtime, we evaluate what's the parameters that we get, and we do something different. You cannot do that with the macros. So I think the macro is not fully a replacement for that, but yeah, I think for 99% of the use cases, it's nicer. Yeah, I hear you, Lucy. Lucy is saying that we need to get rid of the inherent to the protocol dynamism anyway, so that the fact that we do a lot at runtime, and because that would help with making the serialization and serialization reasonably fast. I think what Lucy refers to, she would like to have a compile time interface between the host and the guest. And if you need the dynamism, then you could build it on top of a statically typed non-dynamic dispatching. So you just have a function that's called dispatch, and you handle your own serialization or whatever you need. So something that this also adds is that the way we do the registration here, it adds a trait that lets you take a function that has a signature that we can convert into a guest function, and you can get the guest function definition automatically for that function. So you could do something like register function add dot into function definition, so that all of these will become 1 or 2 lines of code without having to do all of this. And the macro under the hood uses that, but if you wanted to do things without the macro, you could do it in a more succinct way with those traits. And this PR, what it does, it brings a lot of the traits we wrote for the host when we stopped, like when we wrote the new calling functions where you can specify the types with a tuple and you don't have to use parameter values anymore. So it brings those types into the common crate, and then it uses that. So it's reusing the things from the host. That's it. Sorry, I'm not taking any more time.
Cool. Anybody have any comments or thoughts? Comment that all for reducing code, especially if it's done at compile time, even better. Yeah, I agree. I think it looks really positive. I'll have to look and see if I understand. You said what was going on with that flag and what the trade-off was there, but otherwise, I think it looks like a really great improvement.
Yeah, I think the trade-off is that it's if someone wanted to use this, they need to add an extra thing. If we make this something that's enabled by default, then they would get a linking error just by bumping Hyperlight version. So at the moment, I did it as an opt-in feature that you have to enable the macros so that you get this behavior.
Cool. Any other thoughts or comments? All right, cool. Any other items? Otherwise, I think we're 2 minutes away. So we'll go ahead and wrap up this meeting. All right, cool. Thank you, everyone. We'll see you in 2 weeks.
Thanks, y'all.
Okay, James.
Bye-bye.
Bye-bye.
Thank you.
See you.